This t-shirt was brand new when I made that video, but syrup still hadn't happened yet. So let's take the circuitry developed in that video and actually build it using a computer. Okay, so as you can see, we get given a NAND gate, and we're being asked to build NOT, which takes 1 bit and gives you a bit, AND, which takes 2 inputs and gives you a bit, and OR, which takes 2 inputs and gives you a bit. So what we can do is copy these declarations into the syrup window. And let's get cracking. What was the recipe? To build NOT X from NAND, you duplicate the input. So let's see if I take my own advice and add experiment NOT, and OR to the buffer, to the editor, we should be able to see what happens. Let me press send, and it says NOT is defined and has been stubbed out, or has been stubbed out, but at least we've got the correct truth table for NOT. Actually, let's even add experiment NAND so that we can see the piece of equipment we're making use of. Hit send again. And now when we look at the truth table for NAND, we can see that duplicating the input means we're either on 0, 0 getting 1, or we're on 1, 1 getting 0. So that's why this circuit copying the single input of the NOT gate to both inputs of the NAND gate does the right thing. Now let's move on and define AND. The great news is that once we have built our NOT gate, syrup lets us use it. So the easiest way to make AND from NAND is just to use NOT. So AND of X and Y is NOT NAND of X and Y. That's to say, NAND is negated AND another negation just cancels. So let's hit send and we'll see. So now we've got NAND, here's NOT, and here is AND. Observe that we have only a true output when both inputs are true. And finally, let's build OR. We build OR using NAND. Remember, NAND means not both true, and OR means not both false. So the right thing to do is to negate the inputs. So to compute X or Y, you say not both. It's not both the case that X is false and that Y is false. That's to say one of them must be true. So let us hit send again. And you can see that it's happy with all 3 of my circuits, and we have the truth table for NOT and for and for OR that we expect. Now there is a thing that sometimes happens when people are trying to remember these circuits and they can't quite remember, do I negate the input or do I negate the output? Let's play safe and do both. So let me just steal this type. Let's build that safe circuit with 2 inputs and 1 output, where we say, oh, I'm going to negate the output of NAND, but I'm also going to negate the inputs, both inputs for NAND. let's see what this safe component is. See that this safe component is exactly negated OR. So it certainly isn't either of the things we wanted. But it is nonetheless something interesting. You can see it's going to be negated OR because look, this is OR and all we've done is put an extra not on the front. So there you go. You get different things depending on whether you negate the inputs or the outputs or both. Now, the way I like to remember these constructions is that when you're making not, you duplicate the inputs. When you're making and, you negate the output to take the n off, as it were. And when you negate the inputs, you go from NAND to or NOR to AND if you're doing the other version. So there we are. We have built the components not, and, and OR from NAND gates, just like in the video, but in syrup.